shiny machines are consuming the things that we need for survival, removing the future, removing the past. These shiny machines are removing the future, removing the past.
The end of antibiotics. Bacteria are really good at evolving. The weapons we use against them broadly are termed antibiotics. Everyone in the West has taken these at some point in their life when they've had a bacterial infection, and most of you will know how effective they are. You go from being sick to completely fine within 3 days. Before the 20th century, we didn't have or use antibiotics. It came about by accident as Alexander Fleming came back after a weekend and looked at a petri dish, and he noticed that there was a fungal infection that had a radius where bacteria didn't grow around it, and this led to the discovery of penicillin. Since then, we've been using antibiotics through industry and for medicine and therapy. The problem with using antibiotics, though, is that they're very, very good at killing bacteria. Bacteria are very good at evolving, so you set up an arms race where the bacteria that can survive and evolve are the ones that end up completely dominating the ecosystem. Every time we use antibiotics, we increase the chance of an antibiotic-resistant bacteria. The reason for this is bacteria undergo many, many divisions so they can evolve really quickly. And sometimes there's mechanisms in place that actually allow bacteria that evolve more quickly to dominate over those that don't evolve as quickly. Since the discovery of penicillin, we've taken many different approaches to using antibiotics. And when I'm saying antibiotics, I'm talking about chemicals. So we started with penicillin, a small organic molecule, and then we've evolved that to do similar things, mainly with the psyllin-type antibiotics, is disrupting the cell wall. So bacteria have a peptidoglycan layer, and by interrupting the way in which that forms, you can kill the bacteria. One way to think about it might be like bricks on a wall. Bricks on a wall are all off-centered, so it gives structure to the wall and a certain strength from the offsetting of all the bricks. If you lined all the bricks up, it would make the wall significantly weaker. The same kinds of structures exist in the membranes of bacteria. One of the things that the penicillin-type drugs do is affect the ability of that to create a strong structure and instead make it weak, ultimately resulting in the bacteria killing itself. There are a few other classes of antibiotics. There's protein translation inhibitors, there's transcription inhibitors, and a few things that go inside the cell. The most important thing to think about when you're thinking about antibiotics is that we need to exploit differences between the bacteria and ourselves. The main way we do that is through exploiting the cell wall. Protein transcription and protein translation is slightly different inside bacteria, particularly translation. What this means is that we can affect the bacteria's ability to make proteins but not affect our own. The problem with this, though, is the bacteria are so good at evolving, they're quicker than our research and development, and we get to a situation that we're in now that we have totally drug-resistant bacteria. We now have 3 documented cases of totally drug-resistant tuberculosis in Iran, Italy, and India. What does this mean? Is this the end of antibiotics? Often, the West and Russia take very different approaches in science. Since the 1920s, Russians have actually been looking into bacteriophage therapy. Bacteriophages are the natural enemies of bacteria. They're viruses that specifically target individual species of bacteria. They've been around as long as bacteria have, and they've been in a continual arms race with each other across the entirety of life, say 3.5 billion years. Fun fact, there's more viruses that target bacteria in the world than there are bacteria. What are the main advantages of phage therapy? Bacteriophages are specific. They target individual species of bacteria. This means if you have food poisoning or a chronic illness, say you have Staph aureus, you can get a bacteriophage that specifically targets that bacteria without harming the rest of the bacteria. We're finding out more and more that the bacteria inside our guts actually play a really important role in our health. A lot of the nerves in your body and the production of neurotransmitters and different chemicals actually occurs in the gut. Because of this, things like antibiotics can be pretty destructive. Anyone who's taken antibiotics knows that they have to wait until the bacteria recolonize their gut before they have a healthy digestive system again. Bacteriophage therapy allows us to specifically target the bacteria that's causing the problem without affecting the rest of the gut flora. This specificity of treatment, killing one bacteria, is sometimes termed a therapeutic index, in saying that there are relatively few side effects there. Some problems with phage therapy are that in the West, we're cautious to use self-replicating approaches to targeting the bacteria inside ourselves. In effect, you're putting a virus inside your body. It does only target bacteria, but because it can evolve with the bacteria, it can have unpredicted results. We may find ourselves at a situation in the future, though, that these are our only defense against things like this totally drug-resistant tuberculosis. There are bacteriophages that target every single bacteria in nature, but we might not be able to find them easily. Modern molecular biology actually has the ability to design bacteriophages for specific purposes. Bacteriophages are used in a wide range of applications in molecular biology. At the moment, in the West, they're not currently used for therapy, though. This is something I hope to see change. I envision a future where you can go to a GP, find out what bacteria is attacking you, and the GP can print out and specifically design a bacteriophage to attack that specific species and strain of bacteria, enabling you to get better much more quickly with minimal side effects.